Okay, so today is the second session of Introduction to Biostatistics. This will happen after the first lecture, which has been done to the basics of biostatistics. After getting some knowledge from that things, we have decided for the second lecture, and it is totally based on measurement scales. So before going to start the measurement scale, I just want to clear that before this, we have discussed earlier that data is a valuable asset that we have the thing that is the resource. So wherever these resource we have, we'll have to set some things to analyze this data. So before going to analyze this data, we are just checking the demands that either the variables set into it or not. So for these things, we'll have to study the measurement scales. So for the first slide, we have in the measurement scales, we have in statistics the term measurement is used more broadly and is more appropriately termed scale of measurement. Scale of measurement refer to ways in which variable numbers are defined and categorized. Each scale of measurement has certain properties which in turn determines that appropriate for use of certain statistical analysis. So for the first slide, it has summarized that we just have to remember that what type of data we have and why we are going to categorize this data and why we are going to use this data for the analysis. This things comes to be clear in the next slide. So here we have in the next slide the four scales of measurement. The first one here is the nominal scale, the second one is the ordinal scale, third one is the interval scale, and the fourth one is the ratio scale. So the things are very clear. In the nominal and ordinal scale, we are going to analyze the data which are qualitative. This means we have to analyze the qualitative data in terms of nominal and ordinal categories. Similarly, for the last two, interval and ratio scale, these are the continuous scale measurement in which we are going to analyze these two types of data, which is interval and ratio scale. So whenever we are going to discuss the nominal and ordinal scale, first we'll have to read the definition that what nominal scale tells us. In the next slide, you can see this is the definition of nominal scale, which you can see the categorical data and numbers that are simply used as identifiers or names represent a nominal scale of measurement. It do not have natural ordering. Again, it has a series of unordered categories, and these are mutually exclusive. More than one cannot occur at the same time. Here we have some examples of nominal data. Whenever we are going to do any study, we will have some variables in which the first variable are called as gender. It includes male and female. This term has been cleared here that male or a female appears in a study at a time. So the word mutually exclusive, that more than one cannot occur at the same time. Then we have a surgical outcome example, dead alive. Then we have blood type. So many examples here we have. So these are the things which we have discussed here in the category of nominal. Actually, whenever we are going to analyze these things, we just have to memorize that we are going to analyze a nominal data. So we are just fixed here the variables that has been discussed here. Okay, in the next slide, you can see the second category, which is the ordinal category, that is the ordinal scale. An ordinal scale of measurement represents an ordered series of a relationship or rank order. Many categorical variables do have ordered levels. In medicine, ordinal variables often describe the patient's characteristics, attitude, behavior, or status when order is important. The term order is important in the ordinal category, defined as the stage of cancer in the first example here, that every stage has a level: stage 1, stage 2, stage 3, stage 4. So whenever we are going to analyze the data in the rank or in the order, we just have to follow a categorical data which is defined by the ordinal scale. The second example you can see here, education level, elementary, secondary, and college. In the third example, the pain level, mild, moderate, severe. You can discuss it here that pain level, mild, moderate, and severe has some scale, some category. That severe means high, then moderate, then mild. इसी तरीके से अगर आप इससे कैटेगराइज करते हैं और आपको किसी ऐसे तरीके का डेटा यूज करना है जिसमें आपको कैटेगरीज को डिफाइन करना है, तो आपने ऑर्डिनल स्केल यूज करना है. फोर्थ एग्जांपल हियर इज द satisfaction level, which is defined as very dissatisfied, dissatisfied, neutral, satisfied, and very satisfied. So these are the scales where we are going to follow the order. In the last example, we have an agreement level, which is we called as Likert scale grading. It is strongly disagree, then neutral, then agree, then strongly agree. These are the things which we'll cover here in the ordinal scale variable. It is somehow different from nominal, where the order were not important, but in ordinal case we have order which are important. So we have to define the variables in our research that our variable is nominal or ordinal. So things have been cleared. Ordinal have order levels and nominal do not have levels. Similarly, the example shows that how and what we can use in the ordinal set. Okay, in the next slide, you can see here the interval scale, a scale which represents quantity and has equal units, but for which 0 represents simply an additional point of measurement, is an interval scale. Variables that have constant equal distances between values, but the 0 point is arbitrary, that is random. So first we'll have to discuss the definition which we'll have to use in the research study, that we have some interval scale which comes from the continuous data, and when we have the continuous data, we'll have to categorize it in the pain level, that 1-10 scale, or the Fahrenheit and Celsius temperature. In the next slide, you can see more examples of interval scale we have. Yeah, you can see here it is the third level of measurement, and this is for orderly arrangement and equal distance between the data. Example यहाँ पर कोड किया मैंने IQ level. IQ of A is 50 and IQ of B is 100, but it does not have absolute 0. इसकी एग्जाम्पल आप ऐसे समझेंगे कि जो बिहेवियर साइंस की जो रिसर्च होती है उसमें प्रैक्टिस होती है, उसमें एटीट्यूड होता है. तो एटीट्यूड जो होता है वो आपका पॉजिटिव हो सकता है और नेगेटिव हो सकता है, बस 0 नहीं हो सकता. पर जो ऑप्शन है एब्सोल्यूट 0 का, वो आपको यही समझा रहा है कि यहाँ पर 0 एग्जिस्ट नहीं हो सकता, यानी कि आपके पास या तो पॉजिटिव चीजें होंगी या नेगेटिव चीजें होंगी, बट 0 एग्जिस्ट नहीं करेगा. देयर कैन नॉट बी कंप्लीट एब्सेंस ऑफ ट्रेट और कैरेक्टरिस्टिक्स. वी कैन नॉट कंपेयर IQ of A and B with these numbers. Thus, we cannot say B is double intelligent than A, as intelligence cannot be 0. So, these are the variables which mostly used in the behavior science research, where the practices are good or fair or poor, but not 0, because everyone is going to practice what has been telling them. In the next example, we have some attitude. Attitude can be positive or negative, but cannot be 0. So, this is the example where interval scale fits. So in the next slide, I guess the fourth scale we're going to discuss. In the ratio scale, this is the fourth level scale. The ratio scale of measurement is similar to the interval scale, that it also represents quantity and has equality of unit. However, this scale has an absolute 0. No number exists below the 0. Very often physical measure will represent ratio data. Variables have equal intervals between the values, that 0 point is meaningful. Here is the 0 point exists. Interval scale में 0 point exist नहीं करता, but ratio scale में 0 point exist करता है, वो हम अभी discuss करेंगे. And the numerical relationship between the numbers is meaningful. की examples में मैंने यहाँ पर quote किया blood pressure, time, age, body weight, और these are the ratio scales. इसकी second example मैंने लिखी है यहाँ पर height and weight. If one is measuring the length of a piece of wood in centimeters, there is a quantity which equally divide the units, and that measures cannot go below 0 centimeters. A negative length is not possible whenever you are going to measure these things. Okay, in this continuous phase, you are going to see the ratio scale second slide. It is the fourth and highest level of measurement. This is for orderly arrangement, equal interval, and absolute 0. For example, weight of bag A is 25 kg and bag B is 50 kg and bag C is 10 and bag D is 35 kg. Now we can say the weight of bag B is double than bag A, as weight can be 0. We can compare the two data points. Whenever we are going to discuss the ratio scale, we just need to define that only the two variables can be combined each other to define the ratio. As in the researches, we are going to discuss the ratio scale, like what's the male to female ratio in your study. So we can divide the number of male by the number of female to describe the ratio scale. Okay, in the next slide, you can see here the four scales: nominal, ordinal, interval, and ratio. And on the top heading, you can see the indication differences indicate direction of difference, indicates amount of difference, and absolute zero. So you will notice that in the above table that only the ratio scale meets the criteria for all the four properties of a scale of measurement. So the biggest scale here is the ratio scale, but in most of the medical researches we use the nominal and ordinal scale of variables, which is easy to define and easy to calculate. Wherever possible, we'll use the frequency or the some chi-square test or some ANOVA test by using the nominal and the scale variable or the ordinal variable we have. In the next slide, you can see here some points to be remembered. Interval and ratio data are sometimes referred to as a parametric, and nominal and ordinal data are referred to as a non-parametric. First, I'm going to define the parametric and non-parametric test. The data which have a normal or a bell-shaped curve are called as a parametric data, whereas the data do not have a bell-shaped curve are called as a non-parametric data. So parametric means that it meets the certain requirements with respect to the parameters of the population. For example, the data will be normal, the distribution parallels the normal or the bell curve. ये मैं आपको अभी define किया था, जो चीजें यहाँ पर लिखी हुई हैं. In addition, it means that the numbers can be added, subtracted, multiplied, and divided. Parametric data are analyzed using statistical techniques identified as parametric statistics. As a rule, there are more statistical technique option for the analysis of parametric data and non-parametric data that are considered more powerful than non-parametric statistics. A non-parametric data are lacking those same parameters and cannot be added, subtracted, divided, and multiplicated. So this is the, I guess, last slide. आपने slides देख ली, हमने slides पढ़ भी ली हैं, but यहाँ पर मैं ऐड करूंगा कुछ प्रॉपर्टीज ऑफ मेजरमेंट है हमारे पास जिनको हमें पढ़ना बहुत जरूरी है. इसमें जो पहली चीज होती है वो आइडेंटिटी होती है. जब आप मेजरमेंट करते हैं किसी भी चीज की, तो आइडेंटिटी क्या है? आइडेंटिटी रेफर्स टू द ईच वैल्यू हैविंग अ यूनिक मीनिंग. किसी भी चीज की आप आइडेंटिटी बना रहे हैं तो उसकी आप मीनिंग जो है अलहदा से बताएंगे बाय डिफाइनिंग द वेरिएबल्स. फिर उसके बाद जो सेकंड चीज होती है वो मैग्नीट्यूड होती है. मैग्नीट्यूड मीन्स दैट द वैल्यूज हैव एन ऑर्डर रिलेशनशिप to one another that specifies the order of the variables. आपको define करना है कि आपका data nominal है या ordinal है whenever you are going to analyze the qualitative data. In the third case, there is a need to define that what does the interval means. Do you have an equal intervals? Do you have an unequal intervals? Like जैसे हम research study में age के groups बनाते हैं 10 से 20 years, 20 से 30 years, 30 से 40 years. उसके बारे में आपने बताना है कि आपने categories को use करना है या नहीं यूज करना. फिर इसी तरीके से रेशियो का मैं जिक्र कर रहा था. रेशियो में बहुत सारी चीजें होती हैं, जैसे हम जेंडर का रेशियो निकाल लेते हैं, जैसे हम रिस्पांस रेट का रेशियो निकालते हैं. इसकी सबसे बड़ी एग्जांपल ये है कि जब आप कभी भी कोई रिसर्च करने चाहते हैं, लेट सपोज यू आर गोइंग टू डू अ क्रॉस सेक्शनल सर्वे. सो फॉर द सर्वे देयर इज अ नीड टू डिफाइन द रिस्पांस रेट दैट यू हैव सर्कुलेटेड 200 क्वेश्चनायर्स, बट आपके पास जो फेल होके आते हैं वो 180 आते हैं. तो आपने क्या करना है? 180 को 200 से डिवाइड करके मल्टीप्लाई पे 100 कर देना, तो आपके पास एक रिस्पांस रेट आ जाएगा. सो जो आपके पास रिस्पांस रेट आएगा वो रेशियो की फॉर्म में आएगा. आपने परसेंटेज की फॉर्म में उसे लिखना है और फिर डिफाइन करना है अपने रिसर्च में दैट हाउ मेनी रिस्पांस रेट आर पॉसिबल यू हैव. सिमिलरली हम इसको फ्रीक्वेंसी की फॉर्म में प्रेजेंट कर सकते हैं. इन वेरिएबल्स को हम परसेंटेज की फॉर्म में प्रेजेंट कर सकते हैं. इन वेरिएबल्स को हम ग्राफ्स बना सकते हैं. ग्राफ्स में आपके पास बार चार्ट आ जाएगा, पाई चार्ट आ जाएगा, और देयर आर सो मेनी अदर चार्ट्स लाइक स्कैटर डायग्राम है आपके पास. तो इन डेटा को डिफाइन करने के लिए आपको स्केल्स का पता होना बहुत जरूरी है. जब आपको स्केल्स का मालूम होगा तो आप करेक्ट वेरिएबल को करेक्ट स्केल पर स्पेसिफाई करेंगे और फिर गोइंग टूवर्ड्स द एनालिसिस करेंगे आप लोग. और इसी तरीके से जब एनालिसिस ठीक होगी तो आपके पास रिजल्ट ठीक आएंगे, और रिजल्ट्स ठीक आएंगे तो आप कंक्लूजन बिल्कुल सही ड्रॉ कर सकेंगे.